Okay, welcome to Rev 1.4 of the Decode podcast. We have our usual band of misfits with Elias Malfavon Jr., Sean Kincaid, myself, Daniel Stanfill. Who is the guest we have this week? That is Alex. Alex, where do you hail from? Tell us a little bit about yourself.
I hail from the foothills of the Blue Ridge Mountains in beautiful Pilot Mountain, North Carolina. I'm a design and development engineer for a little company called Pro Technologies. I'm a battery management systems designer, so I design the boards that go into battery packs that we build here in Pilot Mountain, and so
Very
that's
cool.
that's what I do. That's who I am. That's it. We don't need to record anymore. That's all you need.
Nailed it. Thank you. It was a great appearance.
Yeah.
So when you say those battery systems, I imagine boards like that are probably pretty heavy ground planes, probably more than your standard copper pour. Like, Sean, what is it? 1 ounce per layer is your standard. So what goes into a layer for your typical battery board?
So normally they're 2 layers. Sometimes we do 4 layers in case if you need noise
Oh, wow.
rejection. But I do have an example right here. So this is a BMS that I designed, and you can see these very large copper pours here, and they're 2 ounce, and that's just specifically for the heat. So they don't have to be near that wide to carry the current necessarily, but that's for dissipating the heat, because over a few milliohms that can add up to watts. 24 volts at 30 amps, that adds up to watts. So you have to be able to manage and dissipate that heat. So yeah, quite large copper pours when you're talking about that. And then assemblers hate that because now the components are coupled to those large copper pours.
Yep.
And so the board has to be preheated, and it makes the process a little more complicated to manufacture.
White. Do you take that into account? Do you just simply design purely for function and, assemblers be damned to let them figure out how they have to deal with it? Or are only the necessary layers connected? I guess you're only dealing with the 2-layer or 4-layer board. So it's not, I guess I'm used to seeing 6, 8 layers and more. I don't think we do anything with less than that. So, many times I'll see only 1 or 2 layers connected to ground and the rest have some relief there. Do you put spokes around the through hole vias or any other considerations for the soldering process there?
No, normally everything is directly coupled. Now we work with a board house who specifically specializes in BMS design, so they have processes in place to deal with that. But no, everything's directly coupled. Any through hole connectors we have, FETs, fuses, the current sense resistors, all that is direct coupling for heat and for maximum current. So the assemblers just got to deal with it. It's just how it is.
Now, is it the case that you have to deal with your designs a little bit as well? I think I've seen maybe you do some prototype assembly. So are you the one that's having to deal with your designs as in-house?
Yes. So in my lab here at PTI, I have a small pick and place machine, just a small Chinese pick and place machine, and I have a stencil station and all of that. And so I'll do 1 or 2 hand-built prototypes, and then normally to get through testing, especially if you're doing UN testing and then IEC testing, you need close to 50 battery packs to do that. So I'll do small runs of 100 or 50 prototypes on the pick and place. I have a reflow oven, and then I'll make all that here. And so I can normally work out a lot of the nuances that an assembler would fuss at by the time I get done with my prototyping process. A lot of the little things.
Do you find that influencing?
Go into that.
Do you find that influencing like subsequent designs? Like if there's a challenge that you face during your prototype effort, you're like, oh, maybe I'm not going to do that this time when I lay out the next board.
Oh yes.
I think that's
yes.
It's pretty unique, right? I mean, a lot of times I think there's a big disconnect between design and the actual assembly process. So I think it's pretty cool that you're doing both ends of it.
Well, I will make this comment, which may make some people mad, but a lot of board designers have never assembled any of their designs. They design it, they send it to a rapid prototype house, and then they get it back and they test it, or they have somebody underneath them test it. And if you never really assemble a board yourself, you just don't understand what the process is. So it's something that I think all designers should have to do, is assemble their prototypes. And the equipment's a stencil station is going to run you about $300. A reflow oven, just a cheap one, is going to be about $300. I modded mine, new firmware, and took it apart and redid some of the insulation in it. I have a YouTube video about that on my channel. And so you could be all in for $600 or $700, company money, and be able to do your own prototyping in-house.
I'm doing this all wrong then. Way too much money I spent.
Oh,
It's
yeah.
prototyping, but
Alex, can you make it even more simpler for me? I need things on that level sometimes. What would actually, like, a battery management system, like what would that actually help out? Like, what is the need? Do you have an example of like a product you built for a specific need, and they needed X and I did this and this is the result because of that?
Yes, this battery pack that I had up here, this is a PTI owned design, so I can show it. But this is a 24-volt battery that can do anywhere from 15 to 30 amps. And this was a need that needed to go into the medical field to power a medical device. And so the reason you have a BMS, so like a lead acid battery in your car doesn't have any safety on it whatsoever. You just plug it up and it goes, right? The older cars don't even have fuses. The newer ones, the block that goes on the battery, it has fuses to protect stuff. Older cars don't even have that, right? And so with lithium-based chemistries, you have to watch out for a bunch of things. You have to watch out for your cell voltages, for your overcurrent and overcharge and those things like that. You have to watch out for temperature, because if you get a battery into too far outside of its parameters, it can go into what's called thermal runaway. And what happens is you have one cell that gets so hot that it starts to melt down, basically. It catches fire and starts to burn. And then that gets hot enough to light the other 4 cells that are glued to it. And then that lights the next 16 cells that are glued to that. And so the whole pack eventually goes up. If you ever seen like a Tesla burning up on the road, they never succeed in putting it out. They always just manage it until it burns out, because there's no way to put it out once it gets started. It's self-fueling. So it will burn until there's no more fuel.
Have you seen the factories that produce lithium when they get a runaway situation in the factories? It's wild. Like, they'll have these pretty advanced systems set up in the corners, these watchdog camera systems that detect thermal, the second there's any type of spike, and it just floods the whole place. I mean, just instantly, just massive flood, and workers evacuate as fast as you can. I mean, it goes quick. So yeah, I imagine. Do you have to? This then is probably getting built to a class 3 standard then, because it's dealing with something critical.
So you mean IPC class 3?
Yes. Sorry.
So it just depends on the application. So again, we don't do anything that's aerospace grade. So a lot of our stuff is class 2. But we usually leave that up to the board manufacturers, and then we just get it in. So as far as the battery pack goes, all of our solder joints and stuff meet whatever that meets the J standard visual acceptance criteria and all of that. But as far as the board classification goes, I am unsure what the class should be, and I should have that answer, but I do not.
Is that product then out in the field, like remotely, or with like I'm picturing like a uninterrupted power supply, but portable? So is that kind of what that device does, or am I off on that?
So it can be used in all sorts of stuff. This, in the medical device this is used in, I have to be generic, because even though this is our property, the application is not. So the medical device this is used in a device that is supposed to deplete, and then you plug it up to the wall and charge it. and then
Okay.
it's just a portable device like that. But we make battery packs for mobile carts that get pushed around. We make battery packs for all sorts of devices.
It's kind of surprising that there would still be a market in the U.S. with how, cheap you could manufacture that overseas, for
Well,
lesser
the
cost.
tariff, I'll be honest, the tariffs will really help with that.
Okay.
So by the time you get the battery manufactured over there, and then you pay all the input tariffs, you're
Shipping.
about what a American-based would be.
Well, that's
And
good.
then on top of that, you have American-based support, American-based testing. See, in our facility here at PTI, we get in the raw cells, plastics, we weld everything, solder everything, and put everything together here, test it, and then ship out a finished product. So
That's cool.
if you've ever dealt with anything overseas, there is a huge disconnect with trying to get any kind of support. And there's no kind of RMA process either. Nothing goes back. It's a one-way trip. And so we've seen a lot of success over the last few years with the tariffs that have been put in, because now people want to work with American-based manufacturers again, because it's about the same price, and then you get all the quality and the support from American-based system.
We need to see more of that on our side. There's too much of it that if it can go elsewhere, it's just too cost prohibitive to keep it here. And we have to try and turn a profit as a business like anyone does. So you can only cut your margins so tight to try to get the work. And eventually, no matter how bad you want it, sometimes you're going to get priced out. You just can't afford to go lower at some point. And especially, if you care about the quality of the product you're delivering, there's going to be a floor that you can't go past, because it's just going to take the time it takes to do the job right. So you're never going to get past that. So that support, that's something that, we try to drive home, that when you contact somebody here, you'll get a response. You're not going to wait 4 days, and you're not going to be trying to chase someone down because something went wrong, and those type of things. Building relationships with people and being a long-term partner. I think that's how American manufacturing can kind of claw its way back.
Yep.
And it's
We
part of the reason
definitely-
why all three of us, our companies, joined the Printed Circuit Board Association of America, because on top of the tariff, they're trying to get a 25% tax credit if you buy from a USA PCB manufacturing company. So if you buy your board, you got the 25% tax credit, and then you get the 26% tariff on top of that. That's 51% increase on, your competition. That could really help out.
I had no idea about the tax credit. That's a good thing to know.
Yeah, they're trying to get Congress on board with it, but it's an uphill battle, right?
Literally what they created, that's what brought them together, and there's trying to be advocates for the industry in Washington and bring attention to the needs. So if we want to be, strengthening our supply chain and keeping our products secure and those kind of things, you got to start taking some pretty serious action. If you look at other countries, they take this stuff pretty seriously. The support that they give, the incentives that they provide to do your manufacturing there. It shouldn't be a surprise where the majority of the work gets done when you look at the boost and incentive and just all the
Subsidies.
assistance and subsidies they get from the governments. We're behind for a reason, and we have to get serious about it. So yeah, a little free plug for the PCBAA, but they've been a great advocate for all of us, and anyone doing this type of work should really, look at it and get involved if it makes sense for you.
Yeah, it's definitely an uphill battle, like Sean said, but you can't win any battle you don't fight, and the PCBAA is fighting that uphill battle, and the hill that they're fighting up is Capitol Hill. So, they're trying to make impacts where it really matters, and they've succeeded in getting the attention of people that can actually make a difference, right? So yeah, good on you for bringing them up, because we're all 3 members and definitely advocate for others to look into it as well. If nothing else, just follow the work that they're doing and be aware of it.
So, Alex, I had a prepared question here because I don't do design work, but I love it. Like, I am super interested in it. I'm fascinated by it. We all follow, Peter on LinkedIn, and he's always sharing super interesting tidbits about how he goes through the bombs and the schematics and creating the layouts and stuff. And I'm just kind of curious what goes into that on your side, and if you can explain it some.
Yeah. So you have a prepared question. I have an unprepared answer. So,
Beautiful.
yeah, anytime I go to start a design, you look at your requirements. So I usually use off-the-shelf BMS chipsets. So I'll look at, what I've used before, what I haven't used before, and what starts the process for me is performance. So I usually don't look at cost, and I usually don't look at the supply chain as much as I look at performance. I want something that I know is going to do the job that I need to do, and that'll sort of back in the other. So if I find a chip that I like, but it's too expensive, okay, I need to find something with similar functionality, but this is my baseline. Or if I need to find something that's more readily available, again, I have that as my baseline. But at this point, I've been working here for 7 years. I've been designing for 5 of those. So at this point, I sort of have all my designs ready to go for, your battery packs standard. You have a 4 series or an 8 series or a 10 series, 15 series. And so you kind of have your designs, you throw at that. And so for me, I'll look at those things, but functionality is the number one priority for me. It has to be able to perform. And sometimes that makes the board more expensive. And either customers will be happy with that or they'll go to somebody else. But that's the number one priority for me is functionality. If you try to pick the components that are cheapest and then you try to make them work together, normally the shortcomings of all the cheap components stack up together. And then your output is just awful. Because
That makes a lot of sense.
You're going, cheap, not productive circuit, and you're just stacking them one on top of each other. So performance is the number one for me. Like if you take an overseas BMS, like you can buy off an Amazon or Alibaba, instead of using, or Alibaba, I guess.
No, it's perfect the way you said it.
Yeah.
I was born in Kentucky, so this all sounds real natural to me. And my wife thought by the end of this interview, I'd be slipping into a drawl. I've been trying really hard not to.
I hope when I grow up I can talk real good, real proper. But take a board like this. This is a 8S. It's a 24 volt board, and it's got a controller on it, an analog front end, and a FET driver on it. That's what it's got. But the overseas BMSs a lot of times will just stack 1 series chip protectors on top of each other. So you have 8 of them stacked on top of each other. The problem with that is your accuracy, short circuit, things like that, your performance is greatly degraded, and sometimes the BMS will just give up altogether because it's not really made to do that, but it's a cheaper way to do that. You're going to save $10, $15 doing it that way. You're going to save a whole lot of money, but now your performance is greatly degraded. The BMS may not last as long. It's not going to be as robust against external influences and situations and abusive situations. So, you just make that choice. But here we don't do that. I'm just going to say it. We don't do that. I'm the only designer here, and I make those decisions, and I choose not to do those cheap BMSs because we have had products that were abused, and that did cause fires and burn people's garages down and things where our products were abused. Now, it wasn't the fault of the BMS design, but they took our product, put it in an unsafe situation, bypassed a lot of the safety on it, and then used it and ended up hurting themselves with it. So we try to make our BMSs as safe as possible. I'll give you another example. We have a consumer device that's getting ready to release that we made a battery pack for. It powers a speaker device. It's pretty neat. And I put a chemical fuse on it. Extra $2 on the board. $1.50 in quantity. The reason I put a chemical fuse on it doesn't have to pass any IEC or any standard that requires a secondary protection. But I put it on it intentionally for the express purpose in case something happens, in case the person decides to abuse it. The BMS is smart enough, if it can't turn off the output FETs, if something's failed there, it'll blow the fuse and completely isolate the pack. That's an extra $1.50 I put in there for the safety of the pack. It didn't save us any money. It's costing us more money, and it's costing them more money. But not burning down somebody's house is worth the $1.50, in my opinion.
So when you do a design, if I understand it right, all these parts, all the capacitors, resistors, transistors, everything has these built-in tolerances, right? So when you build a circuit on paper, just using theoretical values, those are all perfect. All of the theoretical values are perfect, right? But everything has a built-in tolerance. So if you're at the edge of your tolerance on every single component, and then you're using cheaper component, like if you're going the other approach than the one you take, but you're looking to stack up as many of these cheap components as you can, cobble them together, try and make it work. Now you're looking at a lot of components that are by themselves technically acceptable, but when you put them together, it starts putting you way at the edges or outside of the edges of the intended current and functionality of the board. Is that kind of how that works?
Yeah, so you can get in the if you get to the very edge of the tolerance of a component, more than likely in the manufacturing process, you're going to get to the other end of the curve at some point. And so those components will more than likely fail. So my general rule is double. If I can get something that's double rated, double the voltage, double the current, I'll do that, double the wattage. One trick that'll get a lot of new BMS designers is short circuit current. So this battery pack right here has 4 pairs of FETs on it for only one reason. It could do all it does with 2. Heat and everything, it could do all it does with 2. The reason it has 4 is because the cells that we use in here can do 80 to 100 amps short circuit current, dead short, out of one cell. And then there's 6 in parallel. So that's 480 to 600 amps short circuit current. And so if the battery pack is sitting here chugging along at 10 amps and the output shorts, it has to be able to stop that current and cut the battery pack off. And so if I've only got 1 pair of FETs on here, even though they're rated to, that much pulse capability, it can't stop it. The FETs cannot stop it. In the cutoff region, too much heat builds up and it blows the FETs right off the board. And so that's where a lot of these overseas BMSs.
Do you have any videos of that?
In my BMS Design series, I took and shorted the last video, maybe 3.2, I think it is. I took a battery pack out in the parking lot, shorted it out, and it got so hot, the insulator caught on fire, and it melted the wires off of the tabs. That's how hot
That's
it
the
got.
content I'm looking for.
He used Earth as an environmental chamber.
That's it. I made a joke. Everybody appreciated it. I went outside and I said I have to do this outside because my boss said that burning down the lab was not an appropriate use of company assets. So he didn't really say that, but I make jokes like that in my videos.
That's good.
But yeah, everything for battery packs, I usually do double. And then diode protection on your power rails for your chips and things like that, because when you do a dead short, you've got reverse currents. Everything wants to reverse when you do a dead short like that, so you have to protect a lot of things. There's a lot of little nuances in BMS design that's different from normal high speed and digital designs, because you're using power, you're not managing power like you do on a BMS, I guess is what I'm trying to say.
Is it a Zener diode that's reverse polarity?
So that would be, I would use that if I wanted to clamp voltage, but I use a series diode for reverse protection.
Zener or
Just
Zener?
Depending on where you're from, it's like solder or solder. Okay, which one is it? Is it solder or solder?
Wash or worse?
To me, it's solder. What's it to you? Solder?
It's solder to me.
Yeah, solder.
It ain't got no L in it. It's got 2 D's. Solder.
Solder. It's a good. I like that.
So, but yeah, there are a lot of little things with BMS that you got to consider, and we work with a lot of companies. I hate to rap on the engineering industry as much as I am, but we work with a lot of companies where they have their own battery expert, and what the guy was he did the paperwork at a company in the battery department, and he doesn't understand batteries. And we had one company just recently go work with another battery manufacturer because we were so hard on their engineer with the last project, because he was wrong about everything. It's like, we can't help that you're wrong, okay? And so they went to work with another company. They'll be back, but they went to go work with another company. But they'll be back. But because we build all the rest of their products, we have all their equipment here. They'll be back. But you don't have battery experts anymore. We work with with another company, and they're out in California, and they change engineers all the time. Our engineering staff here is how many of us is there? There's 5 or 6 of us that work on engineering stuff, right? And that other company, they've got a staff of 30 people, I think. And what it is everybody keeps changing jobs so rapidly. You don't have any battery experts anymore. You just have engineers. Well, they don't know how to design batteries. Sure, they've got all these credentials, but they don't know anything about batteries. And they change jobs so much, you have to put so much expertise in a room, where it would take 2 engineers to design this. Now it takes 5, because you've got the other 3 researching how to do this thing, because nobody knows. That's something that's lost a lot in our society today, is everybody wants to nobody's an expert on anything. Everybody jobs hops so much. Everybody changes jobs and chasing money and position, that nobody really learns the trade anymore.
Yeah.
Nobody stays long enough to get trained on something or to get good at something. If you look just on our LinkedIn stuff, everybody sharing content is over 50 years old. Most everybody that's sharing expert content is over 50 years old, because the young people are too busy running around and trying to build a name for themselves, and they're not learning anything. They're not getting taught.
It's just a different mindset. I saw a meme that showed, like, two escalators, one's going up, one's going down, and it's captioned, it shows the people going up the escalator the right way as people who are changing their job every 6 months, and then it shows somebody who's trying to go up the down, they're trying to go up the down escalator, and it captions that side, the person who stays at their company for 20 years or whatever, So it's just this mindset that loyalty isn't rewarded, just, be in it for yourself, take the best offer, use every single opportunity as a springboard and platform to the next opportunity. And in that culture, a lot of expertise gets lost for sure. There's no way to pass it on.
Yeah, long gone are the days of, spending 30 years with a company and getting the gold watch at the end and retiring, right? I mean, I think back to just maybe a generation or two ago, my grandfather worked for General Electric, and he spent his entire career there. And I mean, he
Yeah,
knew
wow.
what he did inside and out. I mean, just
Mhm.
absolute expert
Yeah.
level because he lived it. But yeah, I mean, I don't know where that comes from. I imagine that some of that is from both sides of the aisle, right? Some of it's from the employees, some of it's from the employers. But it definitely does seem to be prevalent now. That and folks
I
that
feel
are
like
really good at failing up. I see that a lot as well.
Mhm.
I feel like it's the
Yeah.
big corporations putting the pressure on the little guy, though, right? Like, so, I had an opportunity opening for a purchasing agent, and then I, got some offers back, and then the big corporations around here are literally 2 times the salary that I would offer someone because they just spend, and then they kind of crush the little guy, right? And I can't afford that, there's just no way around it. And I feel like that kind of creates this demand where they jump ship, but it's usually from big corporation to big corporation, right? It's not usually
Mhm.
the small mom and pop to small mom and pop. And if it is, it's a small increment movement, and it's usually due to some type of conflict of ideas of communication or something like that. But for me, that I know that's what I face against is, these. I had this intern come in for an interview. Intern, right? And he's going for his master's degree, right? And I'm not saying he's not certified or whatever, but he hadn't done a single design layout ever of a PCB, right? Can read a schematic, but this guy wanted $150,000 starting as an intern and
Mhm.
never laid out a board before. And it's just
Mhm.
this mentality of like,
That's true.
what? And I'm not even in California, like, okay, if you're in California, Elias's World, sure, whatever, money doesn't mean anything. They just give everybody $1 million. But
McDonald's
in
pays
Michigan,
150 now, I think.
150, man, that's crazy money.
It's a
It's
lot of money.
yeah, and I don't know if they're coming out with unrealistic expectations or these big corporations are biting because they need the talent.
Well, when I take IPC training, I'm in there with a bunch of normally it's a corporate, some form of corporate entity, and they're shoving through 20 engineers or 15 engineers, and they stay for a year or two, and then they move on to the next thing, and they shove another group through, and so it's just the system's broken. The system really is. College costs too much. Everybody's in student loan debt, and then they pump them up in college like there's some great thing, they know it all. Like you
Yeah.
said, had never done a layout before, but expecting the $150,000 because they have this piece of paper. And then you get the ones that never graduate from a book.
Mm.
They
Yeah.
can't Taco Bell at all. They can't think outside the box. They're great.
Yeah.
They're great. I don't know if you've ever worked with them. We have. So if you give them, this is the box you work in, and here's how you work in the box, they do great. They do so great. But they have no aptitude whatsoever. They have no critical thinking, and if you ask them to go outside the box, their whole world falls apart. They just can't do it.
I know the type.
And so I think our education system needs to change to where there's more practical and less
Absolutely.
book work.
Yeah.
There needs to be a lot more practical. And some people may agree with it. You've got to learn the fundamentals before you can do anything. And yeah, you need to learn the fundamentals, but practice makes perfect. You can really learn
Also
a whole
the
lot if you lay out a board.
skills of life.
Yep.
Yeah.
Yep.
Well, speaking of life, how did you get into this life? Did you always want to grow up to be a battery system designer?
When I come out of the womb, I stuck it on an 18650 cell, and I just knew it. My mama said, "You're gonna be an engineer."
There's your quote right there. That's the clip for the.
That's it. That is. Well, I'll tell you, I'm actually a fifth generation engineer.
Wow.
Really?
Fifth generation. I'll explain that to you. See, growing up in the foothills of North Carolina, we're not a rich community. Never have been a rich community. We're not a poor community, but we're lower middle class, that kind of area. And so, growing up here, and my family, and all around Georgia and Florida and all that, my family's grown up. And so from 5 generations back, which is as far as I know back, my great-great-great-grandpa, I've heard my grandpa tell stories. They took an old early model Ford, and he needed a sawmill. He needed to saw logs. He was building a cabin or something, and he took a saw blade and he modified his old Ford to where you could take and attach a saw blade to it, make a mobile sawmill, and he fixed the pedal to where you could crank it down to a certain RPM, put it in second gear, and saw logs with it.
Wow.
They
My
don't teach
father-in-law
that in
did
books.
that. These guys know I live out in the country, and my father-in-law was kind of like a maverick. He just he could slap anything together and make it work, you know. And he did. I think it was an old Ford Galaxy, and he used it as a log splitter. He did that same concept, only made it a log splitter, and he'd just have that throttle going and throw the logs on there, and you know, it doesn't work anymore. Now I get to do it with a sledgehammer and a spike or whatever. But
Yep.
yeah,
So would this be useful
So-
for like a Walking Dead situation?
Probably. Very, very much. I think you had to take the wheel off, though, so you got to figure out how to keep the wheel on it. You take the wheels off so it'll go nowhere, but, you know, if you need to drive through a crowd.
Right?
So
that's cool. When did you say when did you?
that was back in the 20s or the 30s, sometime back
cool.
in there.
Back
And
when
then-
Elias was born.
Yeah, and then my grandpa likes to tell this story. They had an old car that had a mechanical fuel pump. It was gravity fed. It had a diaphragm in there that would pulse and pump the fuel. You know, sort of like a lawnmower runs off the crankcase. The crankcase gases and it pumps that diaphragm, pumps fuel. And he said they were on their way to church one day and the fuel pump quit. The diaphragm cracked in it. So he took my grandpa's shoe, cut the leather tongue out of it, fixed a diaphragm out of it, and fixed the fuel pump and got him home.
You can't do that now.
And stuff like that. My grandpa, he was an electrician and a carpenter. You know, in the Ford Transit vans where they have the console overhead that you can put your stuff in your CB radio. My grandpa was doing that in trucks before it was cool. He would take and make wood and make it to where you could put your CB radio and stuff. He knew electricity. He could wire, do all that stuff. He made just about anything.
Sure.
And so that ingenuity that all these generations had, and then he got into sound systems. And so he would put in sound system in churches and stuff, and then that translated to my father. So up until this point, nobody's had a college education, right? This is all just doing what you do because you ain't got no better.
Salt of the earth.
That just drives you to learn and to do better. And so then my father, he went to college for electronics engineering, and then he got into RF stuff, radios. He got into transmitters, base stations, all that stuff. That was his area of expertise. And then somehow he ended up here in batteries. So he transitioned from that to batteries. And then so I went to engineering school, learned how to design boards, and that's why I'm here today. And that started way back, as far as I can remember, that ingenuity gene, that aptitude. Right now I can do my own carpentry, my own electrical, and my own plumbing. So we got a house set up. I bought an acre of land and got a house put up, and I did all the electrical and plumbing to hook it to the grid and everything myself.
Wow.
I'm
Amazing.
currently rebuilding a rear end in a '02 Ford Ranger. I can work on cars and stuff because couldn't do no better. So we learned those skills, right? And so even though now we technically can do better, we still do those things because we have this. Why pay somebody if you can do it yourself?
Sure.
And you know it's done right because you did it yourself. You ain't got to
Right.
trust nobody.
Right.
And that's lost a lot in our society today. I don't want to say people need to struggle, but if you've never had to do something out of necessity, you won't learn that skill. You just won't. And so way back, 5 generations back, they had to do that out of necessity. There wasn't no other option. They had to work on their own cars. They had to build their own stuff. And then that's just been passed down through the generations. And so now I can do all that stuff myself because my grandpa and my dad taught me, because their grandpa and dad taught them. And so it's just what it is. It's a generational thing. And a lot of that's broken up because people want to ignore what their daddy put in place and what their mama put in place and what their grandparents put in place, and they want to do their own thing. And the generational stuff does work. It does.
So, are you
I'll
gonna
get off my
modify
soapbox now.
modify a car to something crazy like the saw, or maybe it mines Bitcoin while you drive or something? I don't know. Trying to think of
that
something
would
for
be,
today's
that's a
age.
great idea. Mine's
Right?
Bitcoin, because that's the biggest cost of Bitcoin is running the miners. So that's
Right.
a good idea. I like that.
That is a good idea.
Because
full
an
of 'em.
alternator
5%.
Full
An
of 'em.
alternator just sits there and pumps all the time, whether you're loading it or not. It's just a mechanical device, so it just pumps all the time. So you could use that excess electricity off of it, that excess current, to run a mining. That's a good idea. I like that.
You're welcome.
Thank you.
That
I
part
like that.
that part will stay offline.
Yeah,
That is
cut
great.
that. You made some great points there, Alex. I just, it's amazing when there's no easy button to press and help's not coming, how quickly people can actually figure things out, right? It's
Mhm.
just, but I think, modern convenience is such in a way that, somebody will get a flat tire and it's like, well, I'll just call roadside assistance. It's like, change the damn tire. But it's so ingrained into society now that new cars don't even come with a spare. Nobody knows
Mhm.
how to fix it. Yeah.
I don't even know where to find it.
Yeah.
Do you have time for a couple quick equipment questions, Alex?
Yeah, I marked out my whole evening for this. So
Beautiful.
What? Wife's done put the kids down. This is what I got.
So I have a buddy, or I mean, at least a connection, or a connection on LinkedIn that had the uncomfortable conversation with his wife of, what are you moving into the house? Because he actually moved a universal pick and place machine into his house to
I haven't
use
heard
for
this one yet.
prototyping and stuff. And I was like, man, you're a legend. Like, that's amazing. So I'm just curious, like, the equipment you guys use to prototype, how many feeders do you have on your pick and place?
48.
He looks at it.
48.
But it's a tabletop version to where the feeders sit off on the side of it, and then the tape goes in it.
It's just like an open gantry right above
Mhm.
it, and then
Yep.
yeah, okay.
Yep.
Okay.
But that I
What
would have a hard
about
time
your
putting that in my house.
yeah,
I would have.
yeah, the one he put was pretty. I mean, you needed equipment to move it in. I was pretty impressed that he
No,
pulled
two
off.
people can
conversation
carry this
piece.
one.
And then he also had to figure out how to convert it. I think it was 480 or whatever, and he had to convert it to American power to run off of his house. But I've also heard of a lot of people in your situation who are actually using like an easy bake oven and things like that to do their prototyping. But you said you've actually got a full-fledged reflow oven. Like, how many zones?
Yeah. So it's a T962A. If you look those up, those are real popular little overseas units. And then I forgot who makes a upgraded version of the firmware for it and makes it a lot more usable, a lot more programmable. But I think it's got 4 elements in it, maybe, but it would just be, I guess, one zone. It's just it's a fancy easy bake oven. I could probably cook a Totino's pizza in it if I wanted to.
Those are good.
So, the best. If you've ever lived in a dorm, at some point, surely you've survived off of Totino's pizzas when they were 99 cents a box.
I keep Totino's in my freezer now.
Yeah, you should. You should.
And
There's
Dino
nothing wrong with
Nuggies.
that.
And it's not for the
Right.
kids either. I keep the Dino Nuggies for myself.
Hey, they're good.
I went to this Christian boarding academy in high school, and one of the kids was using the oven in the kitchenette there in the boys' dorm, and he didn't take the pizza out of the box. He put the whole box. He put the whole box in the oven. Shockingly,
And
it started on fire.
And then applied for a job asking $150,000.
Yeah, exactly.
I do have
Earned it.
I do have a side thing to go off on here. You can cut this out. But have you seen Food Line has them? They're the pizzas, and you can microwave them now. They're the instant pizzas. You just take and fold the box back, and it has a piece of foil already on it, and you stick it in the microwave. Walmart has them too. You stick them in the microwave, and you just heat them for a minute, and there you go, instant pizza. Little Totino's pizza. Have you seen those?
No.
Oh, they're
Is
great.
it like the
Well, they're
box?
mediocre.
Are you buying the box like including in the product, or is this like a separate sleeve you take your pizza and shove it into?
No, it's the box and everything. It's a little box. It's about this big. It's a 6-inch pizza, and you just fold it open and slide it into the microwave, and it cooks.
I need that in my life.
Well, they had
What
Hot
brand is it?
Pocket.
Well, hey, this is your chance, Alex. You could start off on like a Jim Gaffigan type of career arc and just go into, covering food and Hot Pockets. I think
I
Sean
could.
said that's
Well, I still gotta main the electronics, so it'll be the food and then cooking it with your equipment. That's what
Yeah.
it'll
There
be.
you go.
well, you say side products. I'm surprised with being a electrician and plumber and carpentry and all that. You're not just like flipping houses on the side, buying. Yeah, I bet in your neck of the woods, there's probably some restoration projects that'd be right up your alley. You wouldn't even have to hire any subs. You'd just be one-man band.
Yeah, but he's
It's
got
a
4
lot of
kids.
work. It is a
Yeah,
lot.
it
of
is
work.
a lot of work. I've done one. It's a ton of work.
So it's all we can do to keep up with our own houses. Yeah. So
Yeah.
old
Yeah, I
copper
don't even do
piping.
that.
Copper piping's the worst. So
Yeah.
everything around where we're at was built in the 60s to the 80s, in that range, pretty much. And so copper piping only has a 40-year shelf life.
Mm.
So replacing copper piping and all that stuff. But I thank the Lord for PEX. PEX is great.
I was just going
love
to say
PEX.
that PEX stuff is pretty cool.
Oh,
Yeah.
it's great.
Trenchless repiping. They
Is it
just run
shark
those sleeves
bites?
in
Is
there.
that what they
Oh,
call
yeah,
those
I've seen those,
things?
yeah.
And what about your stencil station? You've got that's on some of your videos, right?
Yeah, I don't know the model number of it, but if you just look up Stencil Station, it's just the generic one with the flip top. Takes, I think a 400 millimeter by 300 millimeter frame or something like that.
I've only
Um,
seen stencil printing options that are tens of thousands of dollars. So I don't know what the do-it-yourself benchtop version even operates like. Does it just have like pegs or something that you lock it in on? And
It's just got a grid of, I think they're 20 millimeter or 25 millimeter holes, just a grid. Then it has pegs and stuff that you can place your PCB in and lock it in, and then the stencil just comes down on top. And then you have adjustments on all 4 corners to balance out your stencil to make sure it's meshing against the PCB
Okay.
correctly and all that stuff.
Yeah, it looks like a Night Bright. Remember those as kids?
Yeah.
Yep.
Yeah, you put the
Yeah.
little
Yeah.
pegs in. Now, is the squeegee on rails? Is that how that works, or is it just fully hand squeegee?
Give me just a second.
All right.
yes, sir.
I can't look at the screen without my eyes looking stupid. I gotta look at the camera.
That doesn't change anything.
It's a little dirty because I don't clean, but there you go. That's what you got. That's your squeegee right there. Your
All right.
manual
It's-
squeegee. So you take your solder paste, you scoop it out, and put it on there, and you squeegee it. That's what you do.
What kind of jar of solder paste is that? It's like for
A very little one,
tiny,
50
tiny.
50 grams, I think, something like that.
I didn't know
Is
they
there a
sold
metal-
them.
Is there a metal blade in that squeegee holder, or is it poly?
Yes, it's a metal blade. So
How do you feel about that, Elias?
Yeah, is that the only way you approve of? Or
That's typical. Yeah. There is a camp of folks that use a high durometer poly blade for step stencils. That's not typical.
High
I'm not a-
durometer?
I'm not a professional house, so it's kind of, my ways would be caveman to y'all probably. But
I
can't
loved
believe you're
your
doing that to the
stencil
PCB.
cleaning video.
Yeah, that
Oh
was
my
awesome.
goodness.
Put it in the
I know it's just
dishwasher.
parody, but
Slayed
I
me.
couldn't believe how well it fit in there. It's just like, oh my gosh, it's so good.
Yeah.
It was so good because even though you included all of the disclaimers, people were still taking it seriously.
People believed me. People
They
really did
did.
believe me.
No, they were like, no, don't do that.
Well, I got some people that were like, "Oh my goodness, thank you for showing me this. This will make it." They were genuinely thought this was real advice. I was like, "Guys, no, don't do this."
I saw
I put
I
like
saw
3 different
15
messages in it too.
I saw a 15% uptick in orders for damaged stencils. Apparently, forks and stencils don't mix well.
No, you only put ceramics in there with it. No metal objects. Your plates are fine. Okay.
See,
So-
those details, that's what makes it, right? Those little extra
Yeah.
BS
Like at the-
details.
At the end of the video, where he's like, "Oh, and make sure you use the China crystal cycle." It's like, that's so
That's right.
thoughtful.
You got to use the delicate. All right. You
Yeah.
can't. You got to be delicate with it.
Yeah,
So-
my wife doesn't know anything about our industry, but she appreciated that video too.
I
She
thought it
pretty
was
funny.
great. I thought it was
Yeah, it
great.
was funny.
The
We
Dawn
need
dish
more of
soap
that.
part was my favorite, where you just
Yeah,
started
lathering it
spraying
up.
Dawn all over.
They were just some old stencils. I'm like, you know what? I'm gonna put it on there.
Both sides, don't forget.
I've got another video idea that I've thought about using a stencil as a cheese grater. I'm not sure if it'll work. I want to try.
I can just see Elias is like, yeah, funny, and like inside he's like twitching and trying to hold it
Yeah.
together.
Yeah, like after you're done, you can use it as a cheese grater.
That's right. After you get done cooking
Tag
your
him in it
pizza,
when you do.
Yeah.
after you get done cooking your pizza in your reflow oven, then you can spread some extra cheese on top of it.
There
That's
you
good.
go.
That's
You've
what,
tied
that's
it
what
all
it
together.
is.
We've come full circle.
That's
Yeah.
it. That's what you got to
You
do.
could
You can
the
use your
pick and-
pick and place for the pepperonis.
Yeah.
Yes. Yes. That is it. Do you guys do
Well-
any kind of test fixtures, any kind of bed and nails or anything like that?
Sean?
Well, I do the flying probe ET test, but for bareboard only. And we haven't answered your question yet. That
We
you
have.
sent. Have we?
We have. It hasn't aired.
Oh, okay.
right?
I didn't
That's
like
what he
your
meant.
I didn't like your response to it. No, but no, seriously, the bed of nails. So your board has to be designed for those type of procedures, like in circuit testing, if you really want to get to check each component.
Mhm.
And that's one thing I hate about board design. I wish you could just plug one end in, touch another part, and then you get a value. But no, each individual component can affect that, right? But the functional testing is so limited, And Daniel actually did have a good answer for why it doesn't happen more often.
Well-
Yeah, I'll cover it again just a little. That a shop like ours is so high mix, low volume that like it's extremely cost prohibitive to try to throw a custom fixture at every type of
Mhm.
board. So generally there's either a very specific type of functional testing that the customer wants, or there's something more complex, but we work together to come up with. I mean, sometimes they already have actual test housing and everything that it
Mhm.
goes in, and you just follow their protocol. But we've got it, bachelor degree in, electrical, whatever, to handle all of the testing procedures and work directly with customers to figure out what it's going to take. Like you mentioned number values in yours, I mean, I guess that's the thing. When people are prepared for the $3,500 or $5,000 fee that comes with building that out, then hey, we're happy to do it, But sometimes when you tell people that are only trying to run a small volume of boards, because to figure out the test on our end, volume doesn't matter. That takes what it
Right.
takes,
Right.
So if they're only going to be running a small number of boards, that cost is going to be so prohibitive sometimes. But
And it's not
if they're
it's
running
not,
at volume, it makes it a lot easier.
and it's not your design too, right? Like you have to play detective. Okay,
Right.
what do they really want from this?
Right.
So, but
Well,
yeah,
I do-
it's
You,
Another thing too, Alex, though, is I don't know about you, Daniel, but I rarely get returns on my stuff, you know, uh, due to some
right.
type of component failure in circuit. Like it's I haven't had one this year. You know, I don't think I did have them the year prior, but that was before I had an SPI. And that thing really cut down on my pads that are underneath that are buried on those type of components that I can't see and touch up with like an AOI. But once I got the SPI, all those went away because it told me, hey, your bridging's happening in solder paste, right? And probably because of the stencil, and but
Yeah, you mentioned
I
last year
mean,
that
we
was
do.
before you had metal etch services stencils in your facility, so that makes sense.
We do a lot of in-process testing and a lot of, in-process inspection. And generally, if something's going to fail, it would have happened in our facility and been repaired before it were ever to leave. You will get the occasional stuff coming back, but there's usually, I can't think of a time where there wasn't an isolated reason for the thing that happened. It's not indicative of something that's just a common part of the process or whatever. It's always something acute that you wouldn't expect to have happened the first time or to happen again necessarily. I know we have had some, I don't know if you deal with this, Sean. We've had some components that have a way higher fallout than is expected or accepted. I mean, sometimes components will have their part per million that is allowable, that for the quality of the part, this many per million are expected to fail. But if you're looking at a much smaller scale than that, but seeing a percentage that's higher than that, you start to feel something else must be going on, and we're trying to get to the root of that because every once in a while we'll have the same part that fails. You replace it with the exact same component from the same batch and it works perfectly fine. So, don't really understand why the same part is working at times and not at others. It's just got to get to
yeah,
the root of that.
I haven't experienced it yet. I'm sure my day's coming, right? But I know I just talked to another CM last week, and he was placing red and green LEDs onto a board. And inside the red board strip of LEDs, the actual reel, every 10th LED was green.
Well, that's
So
annoying.
they were trying to diagnose what's going on, why is this
Bonus.
happening? Yeah, and then they could, it took forever to figure out why is it placing. So they were staring at the machine, watching it. No, it's placing that. It's placing. And then they started realizing, okay, it's every this amount, And the worst part about that is like, there's no I'm sorry for slowing down your line. It's just, okay, I'll
Right.
send you a different reel. You'd be like,
Yeah.
We had a situation happen this week where we had a sealed bag of component. It was IC. It was these ICs on a tray, came fully sealed from the distributor, and it's obviously a polarized part, and they was just all over the place. It just
wow.
wasn't oriented in the same direction through the tray. So we had to have an employee manually turn around like 30% of the tray to get them all aligned in the same direction. And I mean, that's just totally unacceptable. If you don't
Yeah.
realize that, you put that in the machine, counting on the people who gave you the parts to have packaged it correctly, and then boom, suddenly you're at random, you will have improper placements. That's just sabotage.
Yep. So
Alex,
I
I
have
got a
created.
question for you about, do you fear like anything could disrupt the BMS? Because I mean, it's such a huge market, right? Like everyone wants every power to be portable now, right? It's not like the new jet printers, removing all stencil manufacturers. But is there anything that the BMS that could disrupt the industry coming?
No, I don't believe so. There is so much fear around lithium chemistries that they will always. There's so much fear, and then there's so much standards now around chemistries that you'll never get away from needing a BMS. You always need one.
Statement could be like that electronics book you're looking at the other day from the 40s, right? And they'll show this clip and they'll say, "Can you believe this guy Alex said you'll never get away from it?" 80 years ago.
So a good example of that is nickel metal hydride. Nickel metal hydride, when it's abused, puts off hydrogen gas, which is flammable. So when nickel metal hydride first come out, you had to have poly switches, safety, you had to have all that kind of stuff on a nickel metal hydride battery pack. Well, when lithium ion came out, it was way more volatile. And so now there's no testing requirements for nickel metal hydride, and there's all these testing requirements for lithium. So you just stepped, it's the same thing, you just stepped up a notch. Now, nickel metal hydride will still export hydrogen gas, and it's still flammable, but it's not near as dangerous as lithium ion. So
What's after lithium? What's the next mineral that they're going to use?
they're trying to do sodium ion right now, but it's not near as energy dense. Lithium iron phosphate has been around for a long time. It's what we make our large batteries out of. It's a drop-in lead acid replacement, and it's not subject to thermal runaway like lithium ion is. And then solid-state batteries are becoming real popular. So sort of like a pouch cell, but a lot less volatile. You can poke holes in it, you can cut it, those kind of things, and it won't go up into thermal runaway, but it's not near as energy dense. So, you know, I've seen a lot of new technologies in the time I've been in the industry come up and fall. And everybody touts the next best thing. It's going to be the NMC killer, the nickel manganese cobalt killer. NMC cells are going to go away. And guess what? 90% of the market is still made up of NMC cells. Now, form factors are changing. The 18650 is slowly going out of favor and in favor of things like 21700s and bigger cells, but still NMC cells.
Do you ever think we'll be able to get to? I've seen a lot of posts recently about people using nuclear as like a battery. You know, you could basically charge your phone forever, right? With some type of nuclear. They made a car in Russia I seen back in the day that was nuclear powered. Do you ever think it'll move to that anytime in our lifetime?
They tried that back in was it the 80s or 90s? Nuclear batteries. They tried that, and I think EEV Blog did a video about it, and it didn't really work good, and then the technology wasn't scalable. Because the bigger you get it, the more dangerous it gets. So maybe if the technology gets worked out. So it's sort of like the transistor and the integrated circuit. Back in the 60s, you know, when they were sending everyone to the moon, the computers that ran the space program, discrete ICs and all that stuff, and now you've got, microcontrollers that'll do all that are, 10 by 10 millimeters. So the technology does evolve, but it is slowly. So eventually we will see something that'll be more powerful, but it'll always need to be made safe, I do believe.
How did you make sense of transistor theory when you were learning it? Because when I was trying on the side to just delve into design and stuff, I was making it through some fundamentals and stuff and got to diodes, got a little more tricky, and then got to transistors, and I was just like, this doesn't make sense anymore. Like the PNP and the NPN and the whatever, I still remember a few terms like the base emitter and collector and things like that, but how was there any particular book, instructor, what made those concepts click for you, or was it just simple?
A breadboard.
A breadboard, just trying things out.
Mm-hmm.
Yeah, trial and error, seeing the relation between the expected result and what happens, and all that kind of stuff.
Mm-hmm. All the you got BJTs that are current driven, you got FETs that are voltage driven. Then of course you got your P-type and your N-type and your NPN and your PNP, and one is driven low, one's driven high, all those kind of things. So it does get quite complicated. It does.
I know.
And
well, Sean, you can explain. Break it down for us, Sean.
So based on the current orientation of the moon and Mercury really determines what type of transistor and FET you might need. I'd have to look at the current date schedule to tell you which one I would use. But
Depending on the impending solar flare
yeah, it's
and that
I
kind
can
of
tell
thing.
you
If
exactly how I do it.
Mercury's in retrograde or not.
Yeah, I'll just say, hey,
If
to my
the Aurora
engineer.
Borealis is making it that far south at the time, all those kind of factors, sure.
Right, for sure. Or I just say to my
That was-
engineer, my engineer just the other day he was showing me his breadboard, and I don't know why it just always fascinated me. I always wanted to make my own, right, but have it be like permanent, not like something you could plug in and out, just like permanent. And he was showing me that there's like the negative and the power, right? Like and those two strips, and he was showing me like, hey, these two go along this, and this does this, and then because he jumped it over to one, and then jumped it over to the other, and then this, and you're looking at like basically a bunch of wires and some stuff soldered together, but in the background, it's literally counting revolutions per minute on this little thing that he's spinning, right? And that's what's going to happen when he takes the product to the field. And it's just so wild because you look at all these like little wires and you think, okay, what's this crazy thing, right? But it actually works. It's actually functioning, And then the board is kind of just a fancy version of it. But yeah, I don't know. I geeked out on that the other day when he showed me this stuff.
What about crystal oscillators? Do you ever place those in any of your designs, Alex?
No, most of the stuff I do have internal clocks, so I haven't got to. Now I have made boards. Like I took a course where I had to make an Arduino, right? So I laid out a crystal oscillator and all that stuff, and length matching and all that stuff to make sure all that was right. But no, most of my stuff has internal clock.
One of the reasons I brought it up just happened again today. The component has a chamfered pad, so the underneath, the bottom side of the component has one of the pads with a notch on the corner, and the silk screen on the board shows a dot for pin 1. So the component looks like it's polarized. The silk screen calls it to go a certain direction. But you look up the data sheet, and as far as I know, like this was actually something I learned on LinkedIn from posting about this exact component, was that crystal oscillators are never polarized. That as long as it can't go 90 degrees out because it wouldn't line up on the pads anymore, but the 180 orientation, 0 or 180, doesn't matter because the voltage being applied to it, tell me if this makes any sense, the crystal is going to behave to this voltage regardless of which direction it comes from. Is that your understanding of it?
That's my understanding. Like I said, I haven't dealt a lot with those, but that's my understanding that they're not polarized. Now, chip crystals, I'm not sure if they're polarized just because of the way they're internally laid out, but I know that through-hole ones, I don't think it matters which orientation they are. So, not something I'm very familiar with. I'm lazy. I don't do those kind of things. I'm lazy.
Well, I don't know enough about design to know what's a good question, so like whether I don't batteries, so I'd have no idea whether or not crystals come into play with what you do, like I don't have enough of a foundation to even know whether it'd be relevant to your line of work.
I got a question. Have you ever designed a super capacitor?
No, I've never designed anything with supercaps.
My engineer is like obsessed with it, and after he told me what
Break
what
it
you
down.
can,
I know what it is for sure, but for Elias, can you break it down?
you could basically make your own internal power source that could last 20 plus years, and it's going to be costly, but it's literally a backup generator to whatever device you want it for, and it's just these basic giant caps in series. Correct me if I'm wrong, Alex. And they just store energy for you. And then when you're ready to use it, you just plug in. I mean, you'd have to put the right connections to it, but plug and go, and they can last forever. But they're just so expensive. But
What controls the rate of discharge?
what you're using?
Whatever load you have on the output.
Yeah.
Their self-discharge rates are very low.
Now, is that similar? Have
which
you
is
seen?
what allows them to last so long, because it's going to discharge at such a slow rate on its own that you can count on it to reliably hold that power for a long time.
So where would that application be useful? Where would you put that?
Nuclear holocaust. You'd be able to have power. Look at that. See, Alex knows.
No, you can't treat it as a battery.
No.
It's not a long-term storage device. So capacity is your problem. You draw a high current from it, it's going to dump, but it's going to hold charge for a long time.
Right.
At least from my understanding, I've worked very little with supercaps, but we have looked at applications to where you would pair a battery with a supercap for high discharge loads, for high pulse loads. But yeah.
And what about Tesla's new power walls? Have you seen these?
Uh-huh.
Would you consider that like a battery management system?
A very large scale. So I did a breakdown video of the original Tesla Roadster BMS after Elon Musk
I saw
released all
that.
the documentation. And so, yeah, it's a very, very large battery management system. However, something that large, if something goes up in it, it goes up in it. So basically, you're not managing, in something like that, you're not managing safety. You're managing a safety event. So something goes wrong, you need to make sure it doesn't get out of hand. So a lot of the large power walls, you'll see that the sections are in cement bunkers, cement cases.
Wow.
A lot of the large applications, because if something happens in one case, you don't want it spreading to the rest. So you're really managing a safety event, because if one cell goes up, it's going to go up with the other cells, and you need to manage that situation.
Do you ever look at a battery and not think, wow, if this thing's exploded, it would be a bad. A lot of safety features.
There are ones that I worry about. None of my designs, right? Nothing we do here, but there are ones that I do worry about. So, one of the guys that works here, he had a battery out of the company that makes the company that designs a lot of the battery packs for tool batteries. He took it apart because it stopped functioning. He gave it to me, and he had it in here, and it had an analog front end and a microcontroller on it, but it had no FETs. It had no safety outside of a large fuse that could be blown by the BMS, or it could be blown just from high current. That's the only safety feature it had on it. Now, it had all these great monitoring features, but it had no way to cut off the output except for blowing that large fuse.
Did you repair it for him?
That was a design
It was,
flaw, right?
Yeah, I did. So it was the cell stack was just low to where the charger wouldn't recognize it anymore. So the way a lot of these cheap battery companies do, so these drills and stuff, the drill itself has a cutoff voltage. So the drill won't activate past a certain voltage. So that cuts out having to manage that on the battery pack itself. And then the charger won't start if the battery pack is too low of a voltage. So that means the charger will never you don't have to have that in the battery pack. So they take all the safety out of the battery pack and put it into the products. Where that falls through is consumers. Consumers are not smart at all. So they're going to abuse the battery pack.
They don't follow instructions.
They don't follow instructions. They're going to abuse the battery pack. And so they're going to burn their house down trying to fix this battery because the charger won't charge it, because the charger is now the safety, not the battery itself. So by fixing it, I just charged it up to the point where the charger would recognize it, and then it could go.
Yeah, I heard about that with like Ryobi sometimes. If you let the charge go too low, you actually have to take like a trickle charger to it, and then you can put it back on the charger to get it to actually charge again.
Well, now since you've mentioned names, it was a Hart battery, which is made by, it was designed by TTI, which designs the Ryobi and the Hart batteries.
Gotcha.
The reason
a
I
big
know
fan
that is
of
because
Ryobi.
when we took it apart, This ain't corporate knowledge. When I took it apart, I had a TTI BMS in it. That's how I know they designed it. So just
Do
in
you
case
get to
anybody's
do-
listening, we don't make that stuff. That's not a corporate secret. In case anybody's listening.
Do you get to do any destructive testing? Like, do you get to do take apart any things like that for reverse engineering or anything like that?
No, not really, because now if we have a customer who wants us to start making their battery pack, we'll take the other manufacturer's battery pack apart and see how they built it. But most of your construction, your BMSs and all that, there's no secret to how any of that works.
Okay.
You control the output. Now, you may have a custom microcontroller with an analog front end that's running its own program, but it's running the same program an off-the-shelf BMS would. There's nothing else you can do to manage the power, I guess is what I'm saying. There's only so many ways you can make the output to a battery. So there are no, everybody wants to treat BMS design as some kind of voodoo, like you have to sacrifice something to learn about it, but it's really simple. It is one of the simplest design things there is. It doesn't hold a candle to DDR memory. It does not hold a candle to that stuff.
I'm out of all my prepared stuff.
I literally had one prepared question, and you answered it within the first 5 minutes. I'm honestly interested in like stupid stuff like
Yeah, we know.
Bojangles and I was blown away finding out that you told me Pepsi's created in your state.
Pepsi, Cheerwine, Bojangles. Yeah, you need to come down here to eat at Bojangles. Bojangles is wonderful. It's Cajun chicken. You need to get your Cajun chicken biscuit. It's wonderful.
You say cement pretty weird.
Cement. Yeah.
You're telling people
Cement.
they say things weird?
Yeah,
Cement.
I mean, say it's cement. It's cement. I don't know.
Cement.
I got
You
a
ever
question for
poured
you, Alex.
cement?
So, as a design engineer, fucking shot. Cut that. As a design engineer, how specialized you're working on BMS? Can you go into other areas? Could you design a board for different functionality, or is it you pretty much stay in your lane? How broad is the knowledge base of a design engineer in general?
So normally you stay in your lane. You are good at, you go into design. So it's such a broad field that normally you pick out this section and you stay in it. So I design power stuff. BMSs, I design power management systems. So BMSs that interact with power supplies, UPSs, stuff like that. I design those switching circuits and power management and all that. Chargers and charge circuits. Power supplies. That's my lane. So power is my lane. So, motherboard design, I'd have a long way to go in motherboard design. I'd have a super long way to go. But if I needed to make a UPS system to where you plug the battery in it and then you have shore power and you need to be able to switch between those, I can do that. That's my area of expertise. So that's another question for y'all then. Do you have boards that you generally gravitate to? Do you have a certain density that you like to work with? If something's a little too complicated or something's a little too simple, you kind of just say, I don't want to do that. Do you have a lane you like to stay in as far as that goes?
Daniel?
All I've been doing is talking this episode. I like Elias is like what's different from any other. I like matte finishes. I demand it anytime it's possible. People would be surprised, at least I was, that there's such a difference in the behavior of the flux when you're trying to solder something. The matte finish allows the flux to stay active a lot longer during the preheat cycle. So, especially in an application like yours, where you're going to need to drive a lot of heat to it before you start soldering. You're going to need to use a heavy-bodied flux that lasts a long time before it burns off. And a matte finish seems to really help with that. Stays active much longer. That's not necessarily the real answer to your question. We take all industries, anything. My president, CEO, Gary Bales, basically just charged us with, you never say no, or just you never start out with the limitations that you don't currently do, because for the right customer, you just adapt your process to do what they need. So you don't start out saying, we can't do this or we can't do that, because if they're the right customer, then you will figure out how to do that. So he's kind of been coaching me away from saying that we have any type of niche or anything, because, our current customers do come in all shapes and sizes. So I guess we haven't really found one particular thing that we do more of than anything else. I guess pretty broad.
For me personally, it's small pitch BGAs. I don't have an X-ray machine, so I really don't want to. My machine in theory can place it, and we've placed really tiny pads before, but I have nowhere to verify it, right? So everything I do for the most part, 99% of it, I can verify this thing's gonna work. It's those buried stuff, and then once you start getting to a fine pitch, and I can't tell you if there's how much voiding there is on that internally. I don't want to. I tell that to customers up front, and then I usually tell them, like, listen, I can't, if for your warranty for craftsmanship, I can't guarantee it because I have no way to verify it myself. So that way they know up front what I have and what I'm capable of, and that part of it. So really, it's just anything that I can't verify myself visually. Obviously, you have your Bluetooth chips and things like that, and ICs that are buried, QFN stuff like that. That's no problem. But I don't know why, but the BGA scares me. It really does. And so and I don't have a way to test the voiding. So that to me is something that's out of my lane, right?
Well, they're expensive components. BGAs are notoriously expensive. You can't afford to be messing them up. And then on top of it, if you don't have a way of seeing it, then you don't have the confidence to know. We also don't have X-ray ourselves, but we've got one within a stone's throw almost. And anytime we do a new job, we always take, anytime we do a new job that has any bottom terminated components where we can't visually inspect it ourselves, we take the whole first run and get it checked and make sure our process is dialed in, because what you really wouldn't expect would be to see your performance degrade. You'd think if you've got that reflow profile dialed in with that first run, and you're not seeing bridging underneath that BGA and voids and solder balls, underneath there, just waiting to cause havoc at some point. If you've proven you've got a repeatable, consistent process, you can still have some confidence without being able to inspect 100% yourself. But I'd much rather have an X-ray. I'll be the first to say that.
Yeah, and Daniel and I literally have like the same pick and place machine, right? And he's placed thousands of them, And it's just something about me that
and they don't get returned.
Because I haven't X-rayed them probably like you do. You know what I'm saying? To know in your gut, hey, these are probably okay, right? And the ones that were X-rayed are okay, and the process is the process. So, but I don't know.
So it's not necessarily a process capability question as much as, like you said, verification, right? So, where would you say there are some, maybe not necessarily within your company, but where is a manufacturer going to run into, their ceiling or floor in terms of what's capable, like at the pick and place or elsewhere?
Width and height
Each
for me.
piece of equipment has its its capabilities and specs, its tolerances, its its accuracy. Like they all fall in a different range, different tiers of quality, craftsmanship within the machine. So are they all falling within? I think I looked up our screen printer. I say our screen, I looked up the Europlacer's screen printer's specs today, and I think it was the alignment step is at 12 microns of accuracy at 6 sigma, but in general running, it's at 20 microns of accuracy. So, at
Far
6
superior
sigma.
to the
So, yeah, sure. So, yeah, if your screen printing is tighter tolerances and better than what the fabrication of the board is itself, then you can count on that not being the weak part of your process, right?
Well, I've got a secret for y'all, for me, if you ever manufacture BMS. You hear that? I got a secret for y'all. That's you
Yeah.
all. For those of you not from the South.
Yeah.
But
See
the
over at the
secret to
fire.
doing the big copper pores and the FETs and all that stuff is leaded solder. Leaded solder.
Sure.
Now, do you know how you get away with that? Because everything's got to be
No.
RoHS. You know how you
Right.
get away with that? Because battery packs are compliant to RoHS by exemption. Because they have a separate disposal process, they haven't got to be RoHS compliant.
Oh,
So
okay,
we use leaded solder here. We use no clean leaded solder and solder in these big tabs and stuff because they're compliant by exemption.
now you keep mentioning copper pores, right? Like the ground planes. Is that what you're talking about?
Yes, basically huge
So-
ground planes that
On
carry
your
the current.
board, are you doing it on both sides, or are you just doing one side?
I do it on both sides for the heat.
Okay.
So
Yeah.
one side actually carries the current. They'll current share some through the vias and stuff, but the main part of the current's going to be carried on whatever side of the board the power component's on. Then the other side is just for heat.
Because
dissipation.
in the board manufacturing process, when the customer puts a solid ground plane on one side and then just signal on the other side, it is a nightmare in plating. It really is. And the larger your board is, the worse it gets. And then it's same thing for etching, right? Like, so,
Why?
well, it goes back to that ASF, right? So, average square foot of copper, right? So if you have your panel and it's 6 square feet, right? If you're doing 18 by 24 inches, you have all of this copper on this, right? And then you have no copper on this guy, right? And then then you have your sides like this. It's going to take the draw of the average of both and slam it into the tank no matter what. So this side that's lighter is going to get way more copper than the side that's full copper, right? So you have to kind of stagger the plating, one on, basically you run the panel in reverse. So you'll have one board with the ground plane side and then one board with like the signal side, right? And just kind of stagger, and try to do your best to minimize that. But if someone can do a ground plane like Alex is talking about, more throughout it just helps out so much in the PCB manufacture. And for plating wise, and then when you go to etch, right? So all of that thermal shock that you're doing from removing all of that copper is hitting the board on that signal side and not hitting the board on the other. So then you're going to run into maybe some warping issues. But I mean, the board is the board, right? Sometimes you have to do those things in order to get it to work. But I don't know. It's pleasing to hear that you're doing both sides like that.
It wasn't for your benefit, I'll admit that, but I am learning something tonight. I am learning something. So,
Yeah. Well, it wasn't a total waste of your time then.
no, I'm learning something. I need to know more about the PCB manufacturing process. I do need to know more. So designers, we kind of make it and we just throw it over and we just say good luck. There
Pretty
is a
much.
disconnect. I guess y'all know that from
Yeah, and you
experience.
say, why
that-
can't you just test everything fully, 100%, and just, come on, help me
Yeah.
out.
So there is a disconnect between designers and manufacturers. There really is. There's not a lot of back and forth. And you've got organizations like IPC that try to help, but they want to help $3,000 at a time. And so that's not being helpful. It's really not. Now
Right.
they've got a bunch of good stuff, and I've taken their courses about design and things like that. But $3,000 a pop is not helpful. If anybody's listening from IPC, it's not. So, but there is more I could stand to
We'll
learn.
revisit
Certainly.
that sponsorship later. Go
Yeah.
ahead, speak freely.
But there is more I could stand to learn. Certainly about how the boards should be made. Like you said, something. Panels 18 by 24. Is that a standard panel size?
Yeah, either 18 by 24 or 12 by 18. Those are the standard sizes. But you can actually only use a 17 by 23 inch area because there's a 1/4 inch around each of the edges of the board that's used for plating.
How much money would I save if I could change my board size to fit,
Yep.
another pair of,
Leave yourself, depending on the quantity, right? But leave yourself one extra. So say you can fit 5 onto a panel, onto that 17 by 23 inch area, including your rails too. I would order 4, right? Because you want the board manufacturer to have at least one if they mess up in some other process, right?
Okay.
And you probably won't get charged more. Do not quote 1, 2, 3, 4. Just quote 4, because if you give them the opportunity to get you at 3 and 4, they're going to charge you more for the 4 than they would have if you just would have sent in 4 right away. Because they're going to say, okay, I can run 1 panel or I can run 2 panels, X amount of panels. They're thinking in that sense because you can mix designs, but then again, you go back to that issue of you're throwing more copper at one
You're
section
plating.
versus another. Yeah, it's just, and it's possible
See,
it
I
works.
didn't know about that.
Yeah.
So
Well, then you have like certain companies that will use maybe even an electrolysis process, or instead of pattern plating, maybe they're panel plating, right? And it doesn't matter because they just drill the holes and everything gets plated the same, and it's all this high current, and it's quicker times. I think that's kind of how JLC is getting away with it. But
And you're saying when they do that, when they mix customers on the same panel, you might have your design might be calling for a much lesser amount of plating, and the board that it's paired with, that it's running through, needs a lot more. And
Yep.
just by nature, you're going to end up with more than what your design intended.
Yep. And I had this genius idea when I started in this back in 2005. Okay, I was going to offer what's called the proto panel deal. All right. So for $300, you could fit up to 12 different part numbers on this 17 by 23 inch panel. And whatever came out of it, and then we started finding out all of these issues later on, right? Like, because all we did was pattern plating, where it was the same board across, even every time. And then, dude, we'd run these jobs, and then some of the finished drill hole sizes, actually, we had to restart the panel and drill them like oversized by maybe 10,000s, 20,000 sometimes, right? Because it was getting so much extra copper in this one hole that it would literally make it so you couldn't fit your pin through it anymore. It's that big of a difference, in certain cases.
Does it affect both of them? Did you say that the one that shouldn't have as much will actually rob some of the copper that the one that needed more should have?
Yeah, they call it thieving, right? So
Yeah.
it's thieving the copper away from one and giving it to another. Because it's, you got to picture a giant liquid bath of acid copper solution, and then you have sulfuric acid, this stuff called brightener, leveler, and electricity, right? And then they're dancing around, they're all bouncing around there, agitated by water, and then you throw this current at it, and it tracks to the copper onto the panel, right? Poof, 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 poof. And it just does this over a period of however long you want to play for. Depends on how risky you are, but let's say 65 minutes to 2 hours, right? Depending on if you want to go slow and low or fast. And it's just constantly just building up, right? And it's based on the total panel, right? So if this total panel needs X amount of current, it's going to send that current no matter what to the whole panel. It's not going to say, well, he only wants...
Not selectively.
Right.
Yeah.
You're dealing with... our bath was like 800 gallons of water in all of these chemicals in it, right? So it can't be selective on where it goes and stuff like that. I mean, they do make what's called pulse plating now, which can alleviate some of that, right? But it's still... it's not but I applaud you, Alex, for making the PCB manufacturer's life easier by putting ground plane or copper pores on both sides.
I'm learning a lot. I do have another question now. When you talk about panels, do you expect the designer to send you a panel, or would you
I
rather
would
panel it up
prefer a
yourselves?
single circuit.
A
I
single
want a
circuit.
single circuit, and we will build the array, what's best for our manufacturing processes, what's the most efficient, and that's going to work best for you as a customer to let us build it the most efficient way. You'll see that cost savings,
100%.
It's good to know. I don't panel up my stuff, but some of the other designers I know do. I know this one designer. It's either his way or no way, and he's willing to pay whatever for a board to get his way. My boss ain't like that. It's like, how cheap can we get it?
Yeah.
So, you was talking about the plating and the warpage and stuff. He designed a board. We're building a BMS for one of their products, and he designed the BMS that went in it. Well, he did a 4-layer board. The top layer, of course, had your power pores on it. Well, then the middle layer had half a ground plane, and then a full ground plane, and then nothing on the bottom. So the half a ground plane in the middle makes the board tip up. It makes it warp real bad. And so, I mean, they got 10, 12% fallout, but he's unwilling to change, so he just eats that. He just eats it because it's his way or no way.
We had a customer furnished board that would warp that way. We're not in control of the stack up or the fabrication of the boards, so we just have to run what they give us, and it would actually get so bad on the second side it could no longer go through the automation. It would get so warped it couldn't even ride the conveyors anymore. The pick and place back then, I don't know, maybe our current machine, if we were still running into this issue, maybe it would be able to handle that warpage and still place pretty decently, but man, back then it just ruined. You do your first side, send it through the reflow, you see it come out the reflow, and you're like, well, we can't use this board anymore. How do we run this through the machine? And that was a design flaw with the copper inside the board, is what you're telling me.
Potentially. That's the problem with boards. There's like 32 stages just to manufacture a double-sided circuit board, right? Probably over 50 tanks that's passing through. So like to narrow down the actual true root causes, you almost have to play detective at every single stage and then catch it when it happened. There was something I was gonna say. To fix warping, like really bad sometimes, we have these huge, heavy copper blocks, like or you can use steel blocks
For bare boards, right?
Take these super heavy, whatever you can find. If it's some cement, or you put it on top of the boards, and then so we have these giant, they're Grieve ovens, and we run it at 350 degrees for an hour, right?
Yep.
And that heat on that board with that amount of pressure onto it actually flattens out a lot of stuff, So
That seems very, I guess, that seems a lot more primitive than I would think would be a professional process. I guess if it works, it works.
yeah, I mean that's worst case scenario, right?
Yeah.
Primitive is, you're cutting right to the root of Sean's methodology.
Hey,
right there.
When you get your board flat,
no offense,
you ain't gonna be
alright.
complaining.
That's right.
That's true. That's true.
Maybe you shouldn't have told him how the sausage was made.
They used to actually have to bake the laminate before they even ran during production because it was always like
It would
moisture
popcorn in the
sensitive.
reflow?
No, this is like during PCB manufacturing, you'd have issues if you didn't bake the panels prior to. It was just when you drill it, it would mess up. It was just a nightmare throughout all the processes. They came a long way with copper laminate. They really have.
You need to make a video, a good 10, 20-minute video just going through the process. I would watch that.
I would have to have
Absolutely.
a time traveling machine because I don't have any equipment
Yeah,
anymore.
you got rid of it.
Yeah.
You got competitioned out, right?
Yeah. It's like Alex, so like what I'm facing against in the PCB world, we stopped doing it in 2021, so we switched over to just doing full assembly now. And then I'm like a third-party auditor basically for bare boards. And I had a job the other day. It was $49 I got quoted for PCBs, and then I sent it to China for a quote, and it was $5.15, right? And you can't, and I don't blame my customers for wanting to go for that price, because especially on prototypes, man, like you have to prove these designs, and it might have to be repeated, right? And then who's gonna pay, $44 extra a board, That's
10
gonna
times as much,
that's gonna
basically.
add up so quick to so much money, right?
Yeah.
Mhm.
Yeah.
And it's just so that was the
You're
competition
worth
we were
it, Sean.
facing. Yeah, okay.
Your winning personality is worth the 10 times the extra cost.
Yeah, for sure. And it's not like they were. I understand, man. That was like a 16 to 18 hour labor job, right? Just that alone, for $5 for 30 like you can't compete with that. There's just no
Yeah.
way. So, we had to turn away, but I still love it. It's in my blood. It's what my grandfather started doing. What my dad, I was walking in the shop with him when I was a kid, and it's all I ever wanted to do was manufacture boards. And now Daniel forced me into an ESD smock because he doesn't buy circuit boards from me. So it is what it is. Here we are.
I will tell you this. I have heard. Now I have no validation of this, but I have heard that Chinese government heavily subsidizes their electronics industry. That's how JLC, PCB, and PCB Ways and all them places sell so cheap. Is because the government subsidizes very heavily their industry. So
Yeah, it doesn't make sense. Everyone looks at the prices and say that doesn't make sense. How? Because the raw material alone costs more than what they sell it for finished,
Yep.
After
Yep.
those 32 stages, after those 16 to 18 hours, I don't care how much automation you have in the world, right? If your raw material cost is more money than what the finished product is, there's not a robots in the world that can fix that.
Yep.
Well,
Or
we see
human
the
labor.
same thing, and
Yep.
we see the same thing in stencils. I mean, you can procure a stencil from the Far East for far less than the raw materials cost me to make.
And that's what's great to hear about your industry with the BMS, though, is, at least it's still a level playing field,
It is still a level playing field because expertise is very hard to find. So that's still a level playing field, at least for right now. And then they're getting ready to increase tariffs, and so that'll level the playing field even more. So we just need some good American battery manufacturers. Is what we need. That's the
There you
only
go.
that's the only component that's really the big thing. 80% of the sales come from China. So
Is that
80-70%.
is that a
Now
matter
you've
of?
got
Go ahead.
you've got like Molly in Canada. They're producing cells, and then you've got some Japanese cell manufacturers, but most of them come from China.
What about
Is that
Elon?
cost driven? Is that cost driven, or is that more a matter of the kind of environmental compliance in the States isn't friendly to manufacturing batteries?
It's the EPA's fault.
Yeah.
It's a lot of the EPA's fault. And so we have to, the only choice we have is to buy from China.
Right.
That's the only choice we have. Like lithium iron phosphate batteries, only choice you got is to buy from China. That's it.
Yeah, there's no restrictions there. So
And there used to be a few battery manufacturers in the United States, but they've all gone by the way. Molly, they still have a facility up in Canada, and they're still pumping along. They've gotten into a lot of high current cells, and so they're what we call A tier, top tier. I guess if you're talking video game language, it would be S tier because that's your top rank, S tier, right? But they would be top tier. But there's not many left that's not overseas.
well, that's why we were excited to have you as a guest, Alex. We knew you'd be dropping that lingo like that all the cool kids use, keeping us relevant,
That's right.
with a younger audience. Much appreciate that. Do you guys have anything else before we wrap up?
Is it just red in the beard?
No, there's some in the hair too.
'Cause I
It
got
just
red in my
looks-
beard too.
It looks brownish blonde on camera, but there is some red in
My
the hair
daughter's definitely got at least auburn right now. Who knows? And my son was red when but now he's blonde. But
My little brother's got full red hair. My parents, no red hair. The other 3 siblings, no red hair. He's the youngest also, so we were always telling him he was adopted.
as well. Does make you question, don't it?
He'd go crying to mom, and she'd be like, "No, who told you that?" Well, all of my brothers and sisters did.
You don't look like us.
They still had the milkman delivering back then. Those were the jokes made.
have we been recording for an hour and 49 minutes?
Yeah, bro.
Whoa.
Yeah,
that's
time
what
flies when
she
you're
looks
having
like.
fun.
This is great. Alex, we were wondering if we could be able to do 30 minutes on this. Like, I don't know
I
how
was
long.
wondering if I'd be able to do 30 minutes.
Dude, I had
To tell
one
you the truth.
prepared question. You know what I'm saying? And an hour and 49. This could be
Well-
like 7 episodes.
That's
Hey, we could do it too. Hey, we could actually do a 2-parter on this one.
I'll kind of
This
that
would-
extends the shows that we have to do, that we have
See,
in the
this
bank.
is when you get into live streaming, and that's what you do. You just live stream it.
You just
Well, then
go for as long. The problem is that
Sean.
one of us is a live wire, Sean. We won't say any names, but Sean is definitely a problem. So
If I had my own bleep soundboard, for sure. But I would still
If we
want
had
you
a
guys
dump.
to hear it.
The dump
Yeah.
if
button.
we had a dump button,
Yeah.
yeah.
Then you could still hear it,
Mhm.
and be like, oh my God, that was so racist. Why would you say that? Or
Alex,
something.
you probably have that production quality over there. With your studio, probably has the dump button where you can edit out the kids screaming in the background or whatever.
Oh, see, that's why I record at work.
Yeah,
There ain't no kids screaming here.
yeah, same.
do have
Actually,
a-
yeah, the same here.
Well, I took it home for a project, but I do have an Elgato Stream Deck that I have customized for my streaming and recording and things.
Okay,
So
And you're at another
we'll
level
get there
with
one
this.
day.
Yeah.
We'll get there
Well,
one day.
I've been into this for years.
Dude,
You know,
you're
I told you
26.
my grandpa was into sound systems. Well, that translated into my father, and then that translated into me. Well, I got into sound systems and into video streaming. So I put in sound systems and streaming setups on the side. Don't do it much anymore, but I used to back in my early 20s. Back in my day.
Like
Oh,
3
that-
years
But,
ago.
On that hustle. Yeah, no.
But that's how I know all this stuff. It's a generational. Like I said, it's a generational thing. That's how I have all this knowledge. It's a generational thing. So it's just
Yeah, same
it
for
just
Sean
is
and
what
I,
it is.
right?
Yeah.
I mean, Sean's board knowledge is generational, and for me, stencils, it's just, it's what Dad did, and it's what I learned, and
Mine isn't industry specific. It's just generational intelligence. I'm applying it to.
Pops' shirt, generational intelligence.
Elias, you wanna send us out? You wanna say a nice flowery exit?
yeah. We just want to thank you for being on with us, Alex. It was kind of a moment of bliss when you agreed to come on. Obviously, we're in our infancy as a podcast, and having somebody with your reach was much appreciated. And I feel like I learned so much. I maybe have more questions than I did when we started, but when we started this cast, the idea was connecting folks that don't normally talk to each other, and I think we did a lot of that tonight. Having the design aspect of it, the assembly aspect, the board aspect, and these are the conversations we hope to have moving forward. So thank you for your time.
Well, thank you for having me. I did enjoy myself getting to talk to all you old men about your industries. I did enjoy myself. So
Thank you, Alex.
thank you for having me
Thank
on.
you, Alex.
I'll expect my check in the mail anytime.
You bet.
So
You young
Sean
kids
is
don't
on it.
use checks.
no,
Hey,
you just bet money.
Bojangles is on me.
All right.